The distance a car takes to stop when a driver sees a hazard is called the stopping distance. The stopping distance depends upon three things: the speed, the reactions of the driver, and how well the car brakes. We're going to look at the factors involved in that and look at the common mistakes students make in exams. The stopping distance is made up of two parts: the thinking distance and the braking distance. Let's look at the thinking distance first. The thinking distance starts when the driver sees the hazard. It finishes when the driver actually presses the brake pedal. In each case, we're going to assume the driver does is he brakes rather than steers or swerves or anything else. Because the thinking distance starts from when the driver sees the hazard, that means that the driver's visibility, his vision or the fog or whatever, has no impact on it whatsoever. It only starts when they actually see the hazard. Now, slowing down when visibility is poor is vital because you need to have as much time as possible to react to what you see. So what are the factors that affect the thinking distance? Well, anything that affects the driver's reaction time, like alcohol in their system, drugs in their system, tiredness, using a mobile phone. Do you notice what I did there? I jumped between thinking distance and reaction time. They are different. What's the connection? Well, distance is speed times time. So thinking distance is speed times reaction time. That means that speed is vitally important as well as a driver's reaction time. For example, what's the thinking distance of a driver who's driving at 30 miles an hour, which is about 13 meters per second, and they react in 0.6 seconds? Well, thinking distance equals speed times reaction time, so the distance is equal to 13 times 0.6. That's around about 7.8 meters. That's an incredible distance, isn't it, at 30 miles an hour? So the thinking distance is 7.8 meters, around about 8 meters. Imagine that, 8 meters before the car starts slowing down at 30 miles an hour. Speed is absolutely important. Now let's look at the braking distance of the car. The braking distance is the distance it takes for the car to stop once that brake pedal has been pressed. It's now out of the hands of the driver. It is friction and once again speed that affects braking distance. The big factors that may affect the friction are things like worn tyres, poorly maintained brakes, oil and mud on the road, uneven road surface like potholes, ice and water on the road. Please note, you must be specific with your answers. Don't say vague terms like road conditions or weather. If the question says what factors may increase braking distance, make sure you say worn tyres, poorly maintained brakes, water on the road surface. Okay, be specific. So the stopping distance is the thinking distance plus the braking distance. Now, in general, above 20 miles an hour, the braking distance is considerably more than the thinking distance. That means at fast speeds, the actual reaction times and skill of the driver have very little to do with how far it takes for the car to stop. It doesn't matter how skillful you are. People don't seem to realise this. Speed is absolutely vital. Why not test your reaction time by quickly hitting the like and subscribe button? See what I did there? You could also take a look at my website, videoplatoacademy.com, where there's lots of free questions and resources to go with each and every video that I make. I also offer one-to-one lessons and I make those as affordable as possible. So when you get a moment, have a look there. You'll find that pretty useful, I hope. You could also leave a comment as well. I love to read your comments. So the last important fact is if you double your speed, the thinking distance is doubled, but the braking distance goes up by 4 times. The reason for that is your kinetic energy goes up by 4 times when you double speed. There's another video about kinetic energy, so do subscribe and look out for that. For now, watch this.